Chapter 7, Section 4, we're going to be talking about properties of logarithms. So with a lot of these, the better you understand exponent rules, the better you'll be able to understand these, how to simplify these. Remember that when you multiply like bases, you add the exponents. So here we're multiplying base b times base m, and when we do that we add the exponents. That's where the first log rule comes from. It's the product property. When you are, and it's remember that a logarithm is the inverse of an exponent. So if you are adding logarithms, it's the same as multiplying. So here we have the common bases of 3 and 3. So since we are adding them, we multiply these two numbers together to get that one. Okay, so the first example here, the bases are the same. We are adding it, so when we multiply like bases, we add the exponent, so we're working the other way. 9 times 4 is 36. And what would you have to raise 6 to get to 36? And that would be 2. So this simplifies down to 2. Next example, we have common bases. So we have log to the base fifth, and since we're adding, we have to multiply these numbers. 625 times 25 is 15,625. And then we have to figure out 5 raised to what power is 15,625. And so I trial and error, I did 5 to the 4th, which is 625, 5 to the 5th, and it ended up being 5 to the 6th. So this simplifies down to 6. C, we have common bases again. So when we have the common bases, since we're adding these exponents, we have to multiply those parts. So 27 times 1/9 is going to be 3. And then we have 1/3 raised to what power is 3. It's going to be a -1. Okay, quick note, in order to simplify logarithms we must have the same base. If they don't have the same base, we can't simplify them. And our next rule is when you divide like bases, you subtract the exponents. So if we were dividing those, we'd subtract the exponents. And it's going to be the first one divided by the second one. So here it's m divided by n. You can see there's the m, there's the n. So the first one divided by the second one. First example, we have common bases of 5, so when I combine these, log to the base 5 of the first one divided by the second one. 100 divided by 4 is 25. 5 raised to the second power is 25, so this simplifies down to 2. Now we have log base 7. And it's going to be 49 divided by 7, which is going to be 7, and you have to take 7 to the first power to get to 7. Okay, our next example, I'm going to go back to one of the first things I talked about when we talked about logarithms, and that was that this expression right here, okay, we had that expression, and I related it to this, where b was the base, a was the answer, and x was the exponent. So if x is the exponent, that means this entire thing is an exponent right here. So using that definition of log base b of a is an exponent, up here we have a exponent, and then p is the exponent. So we have an exponent raised to an exponent. And to simplify an exponent raised to an exponent, we multiply them. And so we can move the p out front, so p goes out in front, and it's p times the log base b of a. So let's look at this in an example, and it might make a little more sense than what I just said there. Okay, example 3a. We're going to take this 6 and we're going to move it out front because it's an exponent raised to an exponent. So we have 6 times log base 2 of 32. Now I'm going to simplify this expression, and when I'm done I'm going to multiply it by 6 to get my final answer. So what would I have to raise 2? 2 raised to what power is 32? I'd have to raise 2 to the 5th power. So we're going to have 6 times, that simplifies down to 5. 6 times 5 is 30. So my final answer here is 30. Example B, take the 20 and move it out front. Okay, now I have to figure out what power do I raise 8 to get to 4. Now this one might not be clear, but one thing I notice about 8 and 4 is they're both powers of 2. So what would I have to raise 8 to get to 4? I've got to break 8 down, and I know that 8 can be broken down into a third root, and then if I did the third root of 8, I would get 2, and then to get back up to 4 I'd have to square it. That's the same as 2/3. So this expression right here is going to be 2/3. And 20 times 2/3 is 40/3, and that's my final answer. Okay, so that last one was kind of complex. The rest of them aren't going to be quite that tough. So let's look at C now. C, we take the 4, move it out front. Remember, if there's no base written, it's 10. So 10 raised to what power is 10? That would be the first power. So we have 4 times 1, which is 4. The next one we have log base 5, 25 to the second power. So the 2 comes out front. Now we have log base 5 of 25. And 5 raised to what power is going to be 25? That's going to be 2. 2 times 2 is 4. Last one here, take the 5, move it out front. Two raised to what power is 1/2? This tells us we're dividing 2 one time, so that means it's going to be -1. And 5 times -1 is -5. This next rule is actually pretty simple, but sometimes it's hard to recognize. We already talked about this, but exponential and logarithmic operations undo each other. They're inverse operations. So what we're looking at is if we have log base b and then we have the b, that all cancels out because what would I have to raise b to get to b? That'd be 1. So this whole thing becomes 1, and then we're just left with x. If I flip the order around, b raised to the log b, you can see that that cancels out and becomes 1. 1 times x is x. So here it is with numbers. Log base 10. What would I have to raise 10 to get to 10 as the answer? It would be 1. And then you're just left with the exponent. And down here, 10 raised to the log base 10, those cancel out. We're left with 2. So let's look at some examples. So when you recognize log base 3 to the 3, that would cancel out. We're just left with 11. That saves us the step of moving it out to the front and then simplifying. So our answer here is 11. Alright, log base 3, 81. So you can either rewrite 81 as 3 to the 4th power and they cancel out, or you can just recognize that this all becomes 4. So you could have recognized it this way, where those canceled out and you were left with 4. Okay, here we have 5 raised to the log of base 5. That's going to cancel out, and we're left with 10. Remember, if there's no base written, it's 10. So this is log base 10 of 10 raised to the 0.9. So the log base 10 cancels out, and 0.9 is our answer. Here, log 2 raised to the log base 2 cancels out. Answer is 8x. Okay, we'll go over this example when I get back, but briefly, you take, now what I would do in this is I would probably just use my calculator and do log, and then you calculate it as log base 10, and then I would take the answer here and then divide it by log of the base. So the bigger number goes on top, and then the smaller number goes on the bottom. Now you can't put x in your calculator and do a calculation, but if that was a number, you could type it in and get a simplified answer. So for this one, I would probably just use method 1. I don't think if you want to do these other methods, you can. Either way is going to be fine, but method 1, where you change it to base 10, you use your calculator. So it would be log the bigger number on top divided by log of the smaller number on the bottom. Make sure you use parentheses here, and when you type it in and simplify it, you get 0.6 or 3/5. I'm fine with the decimal, I'm fine with 3/5, either one is fine. So B, we would take log of the bigger number, and I mean bigger in size, not quantity. So the 27 is written as a larger fonted number, and then log of the base on the bottom. So log 27 divided by log 9 is 1.5. So 1.5 or 3/2, either one is fine. Last one, log of 16 divided by log of the base, which is 8. So type this in your calculator and you get 1.3 repeating or 4/3. Either one is fine.